Math 1342, Section 1.3, Experiments and Observational Studies, Video 4, Randomized Experiments. In an experiment, the researcher controls the assignment of one or more variables. Remember, that was the definition of an experiment. You're controlling a variable, as opposed to an observational study where you're controlling nothing and confounding variables can wreak havoc on the results. This power can allow the researcher to avoid confounding variables and identify causal relationships if used correctly. But how can the researcher possibly avoid all potential confounding variables? The key is surprisingly simple: a randomized experiment. Just as randomness solved the problem of sampling bias, randomness can also solve the problem of confounding variables. I'm going to inject here for just a second. A randomized experiment does not eliminate all confounding variables. What a randomized experiment does is minimize the effect of confounding variables, therefore giving you more reliable results. So what is a randomized experiment? Well, in a randomized experiment, the values of the explanatory variable for each unit is determined randomly before the response variable is measured. If a randomized experiment yields an association between the two variables, we can establish a causal relationship from the explanatory to the response variable. So you have to jump through a lot of hoops to establish causality. You only have to look to establish an association. In a randomized experiment, we don't expect the explanatory variable to be associated with any other variables at the onset of the study because its values were determined simply by random chance, not by some confounding variable. If nothing is associated with the explanatory variable, then confounding variables do not exist. For this reason, if an association is found between the explanatory and response variables in a randomized experiment, we can conclude that it indeed is a causal association. Example: a college professor writes 2 final exams for her class of 50 students and would like to know if the 2 exams are similar in difficulty. On exam day, she gives exam A to the first 25 students to enter the classroom and exam B to the remaining 25 students. What is the explanatory variable? What is the response variable? Is this a randomized experiment? What might be a confounding variable? Well, let's start with the variables. What is the explanatory variable? What is the response variable? Well, what is causing the results? The type of exam that they got. So the explanatory variable is which exam they got, and the response variable should be the score. I say should be because when I set these things up, it is a lot of copying and pasting from the textbook, so I'm not taking any credit, nor am I profiting from this. And sometimes I copy and paste without looking at the answer first to make sure that I'm giving you my genuine response. The explanatory variable is the exam that the student took, A or B. The response variable is the exam score. Did the score respond to which exam they had? Is this a randomized experiment? What might be the confounding variable? Let's go back and review the definition of a randomized experiment. The values of the explanatory variable for each unit is determined randomly. Were the students randomly assigned exam A or B? And the answer is no. The students who came in first got exam A. The students who came in last got exam B. And you might be thinking, well, the time they showed up might be random, or is it? No, this is not a randomized experiment. The exam students take is determined by when they enter the room, which is not random. Students that arrive especially early may be more motivated, and those that arrive late may be less likely to perform as well. Time of arrival is a confounding variable. So nice try, teacher, but your experiment was not randomized, so your results are not reliable. The following year, though, the professor decides to do a truly randomized experiment. She prints the names of each of her students on an index card, shuffles the cards, and deals them into 2 piles. On exam day, she gives exam A to the students with names dealt into one pile and exam B to the other pile. After grading, she observes that the students taking exam B had much higher scores than those who took exam A. Can we conclude that exam B was easier? Or what we're really asking is, was this a randomized experiment? Were the values assigned randomly? Were the exam types A or B assigned randomly to the students? And the answer is absolutely they were. Yes, this experiment provides evidence that exam B was easier. Only random chance determined which student got which exam, so there's no reason to suspect confounding variables. Yep, that's the last slide on this video.